Alright guys, so we had to go pull this electric motor out of service, and I'm pretty sure you can tell why. It's blown up. But let's take a closer look at this and see if we can figure out what happened. Now this is a 1200 RPM motor, which means we have 18 groups of 4 coils to occupy our 72 slots. Now in between all 18 of these groups of 4, you're going to see this piece of phase paper that's separating these 2 coils here, separating these 2 groups. We want to insulate between all of these groups because they have a potential difference, because the group itself is a different phase and they are at a different point in their sine wave. If we count our 4 coils over from the other piece of phase paper, we can see right where this damage happened. There's a lot of different ways that an electric motor can fail, but when it's failing right where that phase paper is separating 2 phases or 2 of these groups, it definitely appears to be a phase-to-phase short. And if we zoom out and view the winding as a whole, we can see that this is our only damaged area. A lot of people like to throw the term single phasing around, but we would see a pattern, depending if it was connected Y or delta, you would see a pattern of burnt coils around that winding. Unfortunately, and fortunately for us, they need this thing back pretty quickly, which means we're going to have to cut this winding. We're going to have to pull all these wires out. We will count them, measure the gauges. If it's wound with multiple wires, then we're also going to have to figure out the connection itself. We always want to duplicate the manufacturer's winding unless we do find some sort of an error in there. We want to make sure we don't change the performance. There's a few different methods to being able to cut this winding out using a cutoff saw like this, or we could use an air hammer with a chisel attachment to actually cut them. This does give you a nice clean cut, and if we zoom in, you can actually see the separator that is separating right in the middle of that slot. That's our top side of a coil and a bottom side of a coil. Again, we're protecting that potential difference. Although these magnet wires have a thin enamel coating on them, when we're dealing with changing frequencies, those wires are going to vibrate and chafe together and ultimately wear through that enamel and short, either phase to phase or turn to turn. Cheers, guys.